Air is everywhere on the surface of the Earth. It makes up almost all the space around us, and yet students have a really difficult time understanding what's happening with air because it's too small to see. So to help students make mental models about this invisible material, we can use weasel balls and this wooden arena to help them understand with this science snack. You'll need 2 pieces of 2x4 that are 27 inches long, 2 pieces of 2x4 that are 12 inches long, and 1 piece of 2x4 that's 11 and 15/16 of an inch long. You'll also need 8 number 8 2.5 inch screws, 8 number 8 washers, 1 3/16 of an inch drill bit. You'll need a number 2 Phillips drill bit adapter. You'll need a drill, a long clamp, a pair of safety glasses. You'll need 3 self-rolling balls. They're usually sold as pet toys. The brand name of the one we usually get is called a weasel ball. At each end of the 27-inch boards, drill 2 holes. They should be close to the end, but have enough space that they can still fit into the 12-inch boards. Then place the 12-inch pieces between the 27-inch pieces and use a clamp to hold them in place. And then screw in the number 8 screws using a washer. The middle piece is cut slightly smaller than the end pieces so that it can slide smoothly and easily. So now that you've built the snack, you're probably wondering what kind of activities can you do with it? Well, remember the idea behind the snack is to help students make mental models of things that are otherwise too small to see. So this weasel ball is an air molecule. We put it inside of the arena and set it going, it'll bounce off the sides of the arena, and you should have the students count the number of times it hits on the short side versus the number of times it hits on the long side. Now, as you might expect, it hits on the long side more times than on the short side. But over the long run, it'll hit on these long sides twice as often as the short sides do. Each collision is like pressure against the wall, and so the long side gets hit more often, but it's also longer, and those two things will balance out so that the pressure on the long side is the same as the pressure on the short side. If you put 2 weasel balls inside the container and keep track of the number of collisions against the sides, you'll notice that there'll be twice as many collisions as there was the first time. And that's equivalent to there being twice as much pressure if you have more molecules on the inside. And that's, what happens if you put more air in a bottle or something like that. Then you can start using the slider as well. Put the slider in off to one side and then put the 2 weasel balls in. This side will have less area for the weasel ball to move around in, and so it'll hit the slider more often. This side has more space, so the weasel ball will hit the slider less often. So the slider will get hit more times from this side, and that'll start making the slider drift this direction. Eventually, the areas will be the same, and the weasel balls will hit the slider about as often from the right side as the left side. That'll leave the slider in the center. And that's how pressure can equalize between 2 chambers. Now you're probably wondering, how quickly does it reach equilibrium? And with the weasel balls, it's not right away. It takes about 5 minutes for them to reach their new equilibrium, which is great because it means that the interactions happen slowly enough that your students can keep track by counting the number of times the collisions occur. And you can take that to the next level by putting 2 weasel balls in one side and 1 weasel ball on the other side. And then the slider will continue to drift until it equalizes the pressure in the 2 sides. The weasel ball snack is a great way for students to help make a mental model of what's happening with these invisible air molecules, but it's not exactly the same as the real thing, right? The weasel balls can run into each other. Air molecules, that doesn't happen nearly as often. And the weasel balls always move at the same speed, meaning they always have the same temperature. And that doesn't happen with real air molecules either. And these weasel balls are really large compared to the size of the arena, and that's not how air molecules work either. still, it's a good first step for students to try to get a sense for what's happening in air.